Yeah. Hope everyone tried this thing. Chalo. Switching comes everyone. Let's start off. So how do we do this thing? So let's see this. Other scans on. Let's see. The first let's do the main thing is to get the angles. Now the center is here. So from here, drop a perpendicular onto this line. So I'm talking about this triangle here. Can you see how is this? If I call this is the point A. So we want to find this angle here. Let this angle be alpha. So how is this tension here? The tension is actually acting from the center towards this line, T1. Are you getting the diagram, everyone? Look at the T1. The T1 is acting from center towards A. Isn't that how it is looking? So for this triangle, what are these lengths? This length is A by 2, and this length is an half diagonal, isn't it? If you join this thing, this is the length of an half diagonal, which is A by root 2. So from here, we get tan alpha is A by 2, A by root 2. So this is actually tan alpha is 1 by root 2. Everyone got that angle? Great. So once we get tan alpha, how do you get sin alpha and cos alpha? Now listen, this is not a big thing, small technique there. So tan alpha, you got 1 by root 2. So tan alpha opposite side is 1, adjacent side is root 2. So if someone gives you tan or sine or something and you want to find another thing, this is how you can do. So opposite is 1. This is root 2. Use Pythagoras theorem, 1 square plus root 2 square. This is root 3. So from here we get sin alpha is 1 by root 3. Cos alpha is root over 2 by 3. Is this clear? So if I know tan, I can find sin and cos like this. Any doubt so far? Got the angle? No. Look at this thing. So if I draw a plane here, this is the mass m. I'm just taking, this plane in the middle. So this is your mass m. So what are the forces acting on this? This is mg, the weight acting down. And look at the components here. If this is T1, this will be the adjacent side, T1 cos alpha. This will be the vertical component, T1 sin alpha. Is that clear, everyone? So this is how the components is. So this guy will be T1 cos alpha. Similarly, the other string will also have T1 cos alpha, and we'll have two vertical components, T1 sin alpha and T1 sin alpha. And we also have this string here, T2. Are you guys able to see the forces now? So the two strings which are here, this A to center and B to center, T1 and T1, they'll have two components, one horizontal component, one vertical component. But the horizontal component is towards this corner and this corner, like a Y shape. Is this making sense? Later on, you will study this in chemistry, PCl5. The structure looks like this only. We have a phosphorus, we have 5 chlorines like this. If you have studied something like that, you will notice this thing. Any doubts with this picture, please ask me. Clear with this, Ishman, Pratyasha, Shaunak, Tanishka, Yashvi, Utsa, clear with this? Then we're almost there. So what is the vertical forces? 2T1 sine alpha is equal to mg. What is sine alpha? 1 by root 3. So 2T1 by root 3 is equal to mg. So from here I get T1 is equal to root 3 by 2 mg. So T1 आ गया. Is that clear, everyone? And we still need to find T2. Any doubts on this page?
Sir, could you repeat what you have done till now since I was disconnected due to internal problems?
You guys need to do something about this thing, right? This is a disturbance to others also, right, Advai? So please adjust your net. So make sure to do that. Wait, listen till the end. I'll explain you after the class. Stay back.
Okay, sir.
Clear with this? Any doubts on this page? Suno, I'll explain once more. Listen, Advai. So first thing, we are drawing a triangle here. So what did I say? What did I do? I made a triangle here like this, and this triangle dikh raha hai? So in this triangle here, this opposite side is a by 2, and this is a by root 2. So from there, I got the angle tan alpha opposite by adjacent side. I got alpha from there. Now once I got alpha, this T1 ka components, what can I do? I can divide this as T1 cos alpha and T1 sin alpha. Sure. Now the same picture, I'm drawing it like this on a plane. Now see, there are 4 forces like this. So this is T1 cos alpha, T1 cos alpha, and there are 2 T1 sin alphas in the upward direction.
Yes, sir.
Sure, na? So, and then the 2 sin alphas are balancing what? They're balancing the mg.
Yes, sir. That was it.
बस इतना ही किया था. All got this, Shreyansh? Now for the second part. Now again, I'll draw the same square there. Now the vertical components are solved. We have the T1 cos alphas. Those are the problem. So this was T1 cos alpha. This was T1 cos alpha. This was balancing T2. Now you tell me from here, if I drop a perpendicular, what is this side? Isn't this a by 2? Half side. Isn't this also a by 2? Half side. Square hai na? Meaning this angle is 45. Are you sure, everyone? The angles? This is also 45. So now what are the components? So if I divide T1 cos alpha components, we get T1 cos alpha cos 45, T1 cos alpha cos 45. This is T2. This is T1 cos alpha sin 45. And this is T1 cos alpha sin 45. The sin 45 components will cancel. And you're left with 2T1 cos alpha cos 45 is equal to T2. But I already know T1 is nothing but root 3 mg by 2. And what is cos alpha? Cos alpha is root 2 by 3. Cos 45, 1 by root 2. Root 2 will cancel, 2 will cancel. I'll get T2 is equal to mg. Again, all that I taught you was what? Components only, right? I didn't teach you anything new. I'm just dividing into components. But the thing is the angles. So basically, we are dividing T1 into 3 components: x-axis, y-axis, and z-axis. So T1 cos alpha is a component. T1 cos alpha ka component again. Is this clear, everyone? Clear, na, Advay? Devanshi? Ovia? Got this? Any doubts on this? Clear? Next one. So we have a particle with speed 10 meters per second along the line. So we have two questions. Let's say you're going along the line y is equal to 2x plus 1. And let's say you're going along the line 2x plus 3y plus 1 is equal to 0. Find the velocity vector. Remember, what's the vector? You have to give me the magnitude and direction. How will you do this? If you're going along a line, how do you figure out the direction?
Sir, we have to give the answer in terms of I cap and J cap.
Yes. Arya, you have two accounts logged in, yeah?
Sir, I have some issues with connecting to my computer, so I've logged in
Okay,
from
okay. No problems, no problem. I'm just making sure there are no imposters. It doesn't happen nowadays. During the COVID time, it used to be a mess. How do we start? Should I show you the first one? I'll show you the first one. You try the second one. So I'll give another 30 seconds. Let's see. Look at the first one. You said y is equal to 2x plus 1. Now we studied this in school. So this thing looking like y is equal to mx plus c. So the slope is m, which is nothing but tan theta, is equal to 2. Agreed? So for this thing, so this line equation is looking something like this. So this is the line y is equal to 2x plus 1. So this particle is going with the velocity 10 meters per second. And it is making an angle theta here, isn't it? So what are the components of this? This will be 10 cos theta. This could be 10 sine theta. And just now I taught you the technique. If I give you tan, how to get sine and cos. This is theta. Tan theta is 2. Opposite side is 2. Adjacent side is 1. This is root 5 from Pythagoras theorem. Sine theta is 2 by root 5. Cos theta is 1 by root 5. There, if I give you sine or cos or something, I can find the remaining by making a right angle triangle. Therefore, the velocity vector v bar will be, now remember, the particle could have gone backward also, right? There are two possibilities. You can go front or back. I didn't tell you which way. So your answer will contain plus or minus 10 cos theta I cap plus 10 sine theta j cap. You know cos and sine, so substitute there. So 10 by root 5 I cap plus 2 j cap. That's your answer. 10 by root 5 is how much? 2 root 5. Okay, what we did? End of the day, I know the magnitude 10, and if you give me the angle, my job is done, right? So if instead of giving you the angle, indirectly I gave you the slope, and from there I'm telling you to find the angle. Is that making sense? Yeah. Now using this thing, can you do the second part? 2x plus 3y plus 1. I'll write here 2x plus 3y plus 1 is 0. Have a look at this. Try for 2x plus 3 plus 1. Get it? Now it is easy. Remember, unlike straight lines, right, vectors can be moved. So this plus 1 is actually useless for us. You could have taken y is equal to 2x, you would have got the same answer. Because if you move the vectors parallelly, the answers won't change. 2x plus 3y plus 1. What is the answer for that? Get that, get that. Another 30 seconds. Hmm. 2x plus 3y plus 1 is 0. This is y is equal to minus 2x by 3 minus half. The slope is tan theta is equal to minus 2 by 3. It's an obtuse angle. So if you try to draw this line, you'll actually get a negative slope. When you put x is equal to 0, I'm getting y is equal to 1. So this is how the line will look. Hope everyone knows how to draw the line, right? Put x0, you'll get y coordinate. Put y0, you'll get x coordinate, and then you're done. So this guy is going something like this. And remember, the angle you got is this angle here. Tan theta 2 by 3 is that angle. Isn't it? It's an obtuse angle, right? With the slope. That way. So I can take this angle as pi minus theta. So let's say you are going this way with 10 meter per second. Same story. So I can resolve this into components. This angle will be pi minus theta. So velocity vector will be again plus or minus. You can go in any direction. 10 cos pi minus theta I cap. It's going to the left. Actually, now if the theta is confusing, you can just ignore it and solve it like a normal thing. The signs will take care of itself. Plus sine pi minus theta j cap. So how much is this? Plus or minus? You guys know, right? Trigonometry basic cos pi minus theta. How much is cos pi minus theta? It will become plus cos theta I cap. And this will be sine theta j cap. Cos 180 minus theta is minus cos theta. Sine 180 minus theta is plus sine theta. There, but how do we get this thing? So this is theta, tan theta is minus 2 by 3. This guy will be how much? Root over 9 plus this 13. You can substitute here plus or minus. So cos will be, I need to understand which will be minus here. The x will be minus, y will be plus, because you can see it is going in the second quadrant. The second quadrant, x is negative and y is positive. So that minus actually belongs to the 3 ka thing. You need to know that thing. So 3 by minus root 13 I cap, 2 by root 13 j cap. Clear with this? This is a little, pi minus theta and all that stuff. If you're confused, right, keep it simple. Just draw the line regularly. Don't worry about anything. Let it be anything. So this is v, this is theta. So velocity vector will be 10 plus or minus cos theta I cap plus or minus sin theta j cap. And we know tan theta is equal to minus 3 by minus 2 by 3. So make a triangle here. So just put minus 2, 3. Because that plus or minus is there, that will take care of the answer actually. And this guy will be root over 13. So this will be plus or minus 10. Cos theta will be 3 by root 13 I cap. This will be minus root by 2 13 j cap. You will get the same answer. It won't matter because there's a plus and minus outside. The signs will take care of themselves. Is that you're getting it? So no need to actually draw the line theta, pi minus theta. Need not do anything. Just put it there and finish it, or you'll get the answer. And it won't even matter whether you take minus on the top or the bottom. See, if you take minus on the top, this will be minus. But remember, this is plus and minus, right? I can always send the minus inside, plus outside. It comes out to be the same. The two answers will look same. Clear with this? So there is no need to do it exactly drawing a picture. Even if you don't draw the picture and solve, the answer will take care of itself. But got it? So if I give you a line and if I ask you to get a vector, this is what you do. So lines and vectors, they're a little different. So be careful with that. Next one. Everyone got this? How to get a vector from a line? Srihari, Sidesh, clear? Next one.
Yes, sir.
Any doubt so far? Utsa, Ashwi, Trishi, Ananya, Triyansh, Devanshi, Advait. Perfect. Next one. Don't hesitate. Do make sure to ask. This is a good one. So we have a circle. We have a particle going with speed u. T is equal to 0. So this particle goes along the circumference. After time t, it reaches somewhere here. It is going with u and it makes an angle theta. So theta is given in this case, which you can find actually with time t, but okay. A particle moves in a circle of radius r. With constant speed u. First question, find the initial velocity vector. V bar is velocity. Find the final velocity vector. Final meaning at time t. So I'll just write the full word, initial velocity vector. Find delta V bar. Delta V bar is V final minus V initial. Find magnitude of delta V bar. So this is the magnitude of change in velocity vector. So what is delta V bar? Delta V bar is change in velocity vector. V final minus V initial. Delta V bar is the magnitude of change in velocity vector. A, B, they're related, all are related. And this D part result should definitely mug up the result. You should remember the result. Exam like means or bits, right? That's a direct question in the exam. So I'll be putting stars wherever we think it is important. Exam, you won't have time to derive that. In exam like bits has 130 questions in 3 hours. So you will barely get like what? A minute, 20 seconds per question. Yeah, the initial velocity is easy. Initially it is in which way? Pointing up, na? So u j cap. Bas itna hi the initial velocity. So find the velocity at an angle theta, find the change in velocity, find the magnitude of change in velocity. Get them all. Right, Samak. Get the D part answer. I'm more interested in the D part. Try. Everyone try. For a minute, I'll show you A and B in a minute. Then I'll give you another 1.5 minutes for the C and D. Anyway, in case you're confused, I'll just help you out. See, this is the final, right? I'm just asking you to divide U component and U vertical component. That's it. Just give me answer in terms of I cap and J cap. Means you need to find this angle. If I can find this angle, my job is done. If I know this angle, that will be cos alpha I cap and sin alpha J cap. Let's see. So what is the initial vector? That was easy. You're just pointing in the upward direction. So it is U J cap. You're pointing in the Y direction. Next thing, draw a parallel line. If this is theta, then this angle will be 90 minus theta. So the final velocity, we have U this way, and this angle is 90 minus theta. So this component will be U cos 90 minus theta. And this vertical component will be U sin 90 minus theta. U sin 90 minus theta is nothing but U cos theta. U cos 90 minus theta is U sin theta. If that looks confusing, you can take this as theta. Then this becomes U cos theta, U sin theta. Same thing. So therefore, V final will be the sin theta is pointing backwards. That is minus U sin theta I cap. U cos theta is pointing up, U cos theta j cap. This is how you find the velocity vector. What is change in velocity vector? V final minus V initial. So just subtract them, you will get it. Then get the magnitude of that vector. Now try, I'll give you a minute. So if I know A and B, I'll get C. That is simply V final minus V initial. But what is the magnitude of that? Any doubts on this thing? How did I get the component? What is the angle? Anything you're not clear, please ask. Oh yeah, you can still simplify that. प्रॉब्लम वो है एग्जाम में ऑप्शन ऐसा नहीं दिखेगा. The hint is here. The hint is here in this page. See. Understood. And I told you it will come. What is V final here? So V final is this thing minus U sine theta I cap plus U cos theta J cap minus V final is U J cap. So bring all sine thetas I cap together. U sine theta I cap and bring all J caps together. U cos theta minus 1 J cap. This is your velocity vector delta V. Near samyak, that's not the answer. Now you want the magnitude of this vector. So magnitude of delta V bar is what? The root over coefficient of I square, coefficient of J square. That will be root over U sine theta ka square plus U cos theta minus 1 ka square. U cos theta
Sir,
minus U, that is.
minus U, right?
Yeah. Minus U tha wo. Square. You're done. Expand this. U square sine square theta. U square cos square theta minus 2 U square cos theta plus U square. Take out U square common. You'll get sine square theta plus cos square theta is 1 minus 2 cos theta plus 1. Take out 2 also common. Okay, let it be inside. So it'll be 1 minus cos theta. You must have got till here. Most people get till here and then people get stuck. Now you need to remember this result. 1 minus cos 2 theta. There, go back to this result. Say. Can you see this result here? 1 minus cos 2 theta by 2 is sine square theta. This is the result we are using. 1 minus cos 2 theta by 2 is equal to sine square theta. But here we don't have 2 theta, we have theta. So replace 2 theta with theta. Then what will happen? See, this will become 1 minus cos theta by 2. This becomes sine theta by 2 whole square. Sine square theta by 2, isn't it? So if you are replacing, or think of like this, replace theta with theta by 2. That is better. You're getting it? So the formula becomes like this. Now substitute it here. So 1 minus cos theta is 2 times sine square theta by 2. You're done. So this will be u into root over 2 into 2 sine square theta by 2. You get a pretty good result. 2u sine theta by 2. This is the magnitude of velocity. And you should remember this thing. So exam mein they asked a question like this. They said a particle is going in a circle. It is going with speed v. It has covered an angle 60 degrees. Then it reached here. They asked find the change in magnitude of find delta v. So the change in speed, change in velocity का magnitude will be 2v sine theta का इसमें 60 is there, 60 by 2, which is 2v sine 30, which was v. This was a mains question. Long back, but this is the kind of question you'll get in CET or bits. Mains may, if you're lucky, you'll get something like this once in a while. You should know the result. If you don't know the result, then you have to derive all this stuff. Clear review. That's the result. Next one. Next one. Any doubts on this page? This is all max. There is no physics in this. So once you got the square, you're done actually. Physics got over here. Next one. Triangle of vectors. So what triangle of vectors is if two vectors are joined head to tail, the resultant vector is from the remaining tail to the remaining head. What do you mean by that? See, think of like simply, let's say you're walking from here to here, A bar, and then you walk from here to here, B bar. So if I ask you what is the displacement, what will you say? If you ask any person, how did you walk from here to here, what will they say? They will simply say you walked from here to here straight, isn't it? So what this thing is simply saying is, if you go from this way and if you go this way, it is as good as walking from this tail to this head. Does it make sense? So basically it's a displacement vector. You can think of like this. So this would be your resultant. So we can write R bar is equal to A bar plus B bar. That's it. That's a triangle law. If you walk from here A and if you walk B, it is as good as walking along that red line. Now extension of this. So if you take three vectors are joined head to tail, forming a triangle. Then the resultant vector is a zero vector. What do you mean by this? Suppose if you take a vector A bar, then you walk like this, and then you walk back here. Did you see? This is an important statement. Huh? You have to join all heads and tails. Now you tell me what is the displacement? If you start here like this and like this, what is the displacement vector? Zero, right? You didn't travel anything. So that's what the statement says. So if you take three vectors and if you join them head to tail and you form a triangle, they come back to the same place, then A plus B plus C is zero bar. Make sense? That's it. It's not a big law or something, simple thing there. Just think of displacements and you'll understand this. So this thing gives you an idea that if three vectors can form the sides of a triangle, then you'll get a zero resultant, isn't it? Next thing. All clear with this page? Meaning with three sides, you'll always get a triangle, right? You'll get a scalene triangle. Yeah, it won't be symmetrical. Yeah, it need not be an equilateral triangle. If that's what you're trying to say, I'll make one for you. See, this is A bar, this is B bar, and this could be C bar. Yeah, it could be something like this. Need not be equilateral triangle. It could be anything. Next one, angle between vectors. This is an important one. People do get confused. So again, we have to define this. So when two vectors are joined tail to tail, or head to head, the smaller angle between them is the angle between the vectors. Meaning, suppose if someone, this is how you add them. So if this is A bar, this is B bar, you have to put them tail to tail. Then this is the angle between the vectors. Example, if someone gives you like this is A bar, this is B bar, and let's say they give you this thing as 120. What is the angle between the vectors? It's not 120. So first thing is look at this thing. Here the tail and the head are joining. So first you need to shift them. Can I push the vectors forward? Can I push this vector A forward? Because vectors will not change. So if I push this vector forward, I will keep B bar as it is and I will shift A bar forward. I will make them join tail to tail. So if this angle is 120, this angle is 60 degrees. There. So angle between vectors is not 120, but 60. So be careful. So 60 degrees is angle between A bar and B bar. Easy? Let me give an example. You tell me what is the angle between these vectors. Suppose if I make three vectors like this, A is equal to 3, B is equal to 4, C is equal to 5, a right angle triangle. Find the angle between A bar, B bar, and C bar. Get this? So we have a 3, 4, 5 triangle. This is how they're given. You have to be careful. Those angles are wrong. It is not 37, 53. Remember the definition. You have to join them tail to tail. Then you have to get the angle. Here, all the vectors are joined head to tail. Unfortunately, 37, 53, 90 will be one of the options. You'll mark it happily and you'll get a -1. Think. I'll give you 30 seconds. Oh yeah, just now I told you that is wrong. Right, Ishman. You guys are getting confused. See, let me show you this. So this is the thing, right? This was 3, this was 4, and this was 5. This angle is 53 degrees. This angle is 37 degrees, and this is 90. But I can't use these angles. So what we do, we need to shift them a bit. So shift them. Shift A forward, keep B here, and shift C here. You're getting it? You have to join all of them tail to tail, isn't it? So angle between A and B, that is easy, 90. Now what is the angle between A and C? Look at this. This was C, isn't it? I shifted it downward. If I had extended like this, right? Look at this thing here. If you extend like this, what was this angle here? This was 143, isn't it?
Yes, sir.
So the angle between this and this will be how much? That is the angle between B and C. So this angle will be, wait, I'm not drawing that properly, I guess. Yeah, look at this angle here. That is 53. What is this angle here? 127. So this angle will be 127. Are you able to see that? If you push the C down, it will meet A here. So that is 127. Total must be 360. So this angle will be 143. This is how you measure the angles. You don't take 37 and 53. So angle between A and B, 90 degrees. Angle between B and C, 143 degrees. Angle between A and C, 127 degrees. Sum should be 360. Clear with this? See, you have to go with the definition. The definition says join them tail to tail. Here in the question, I gave you everything head to tail, head to tail, head to tail. So these angles are wrong. You have to bring all the three vectors, join them tail to tail, and then get the angles. Arya.
Sir, in the exercise, there was a question like this, but I could not solve it.
But is it clear now?
It's still not clear. Shall I ask the doubt right now or after?
You can ask all of it after that class.
Okay.
Let's see one more like this. If that's confusing, let me give you one more. Suppose if I give you this guy, let's say A is equal to 1, B is equal to 1, and C is equal to √2. Now what are the angles between them? Find the angle between them. Every time it did not be a right angle triangle. So be careful. You can push the vectors along the vector or parallel to themselves. You just have to join them tail to tail. Get them both. I'll give you a minute or two. And make sure total sum 360 आना चाहिए. You can just verify. Let's see. Listen again, in case you're getting confused. What I will do, this is A bar, na? Let me color them. So I will put A bar here. This is B bar, right? I will shift it to the left. This is C bar, na? I will just push this down. Able to see this thing? Now look at these angles here. This was 45. This was 45. I don't want these angles. This is 90, B, A and B. That is okay. So if I extend this vector, if I push that sky blue line downward, this angle will be 135. So this angle was 135. Is that making sense? Similarly, if you look at this thing, if I had pushed this green line upward, this angle would be 135. This is also 135. So the angles between the vectors are 90, 135, 135. Is that clear, everyone? That's how we get the angles. Join them tail to tail and then get the angles. Same thing I can do here. Shift A forward, then shift B this way, then shift C this way. So if I extend this thing, this angle will be how much? 180 minus 40? 140. So this angle is 140. Extend this thing line here. So this will be 180 minus 60. 120. This is 120. Extend the line this way. So this angle will be 100. This is 100. Got the angles? 100, 120, 140. Is this clear, everyone? So you can't take the angles in the triangle directly. It won't work. Arya, is this clear or still the doubt the same thing? No, you still have that thing. We'll see end of the class then, no worries. Clear with this? All got the angles? Great. Next thing. section formula. I'm pretty sure you studied this in school, but let's see how do we use that in vectors. So if you have 2 points here, let's say P1, let's say P2, let's say this is x2 comma y2, and let's say this is x1 comma y1. And let's say there is some random point here. Let's call it P, which is dividing in the ratio of m is to n. So P1P by P2 will be in the ratio of m by n. Let's say this is your origin. So this vector will be how much? Let's call it R1 bar. This vector will be R2 bar. So I want to find what is OP bar. This is RP bar. Now, you can find the coordinates using the section formula there. So this is how it would look. So we get m by n will be in the ratio of P1P by PP2 cross multiply. We'll get m into PP2 bar is equal to m1 into P1 P bar. PP2, yeah. So m into PP2 bar and into this thing. And what is PP2 bar? Just now we saw from the triangle law. Look at this thing. So PP2 will be what? If you want to go from here to here, it is as good as going this way and this way, isn't it? Down and then to the right. So PP2 will be, you can come down. So that will be PO bar plus OP2 bar. Similarly, P1P means if you want to go from here to here, it is as good as going down and then going this way like this and like this. So you're traveling from P1 to O and then you're traveling from O to P, you will reach P1 to P. Is that making sense? Forget about triangle and everything. Just keep it simple. You want to go from P1 to P. I can go directly or I can go from P1 to O and then I can go from O to P. Won't I reach P again?
Yes, sir.
That's it. That is a triangle law basically. Yeah, and you can just rearrange the terms here. What is PO bar? PO bar is minus RP. Because we said OP is RP bar. OP2 is R2 bar. This is N1 into P1O is minus R1 plus OP is again RP bar. So bring all RPs to one side and this is on that side, you will get this. So this is the result. RP bar will be simply M into R2 plus N into R1 bar by M plus N. This is the result. So this is your section formula in terms of vectors. Using triangle, but there's a much better way. Huh? This is too long. What is a much better way? If I know x1, y1, if I know x2, y2, if this is m and n, what is the x coordinate of this? M into x2 plus n into x1 by m1 plus n, right? I can find the coordinates of this point directly, and then I can finish off with a vector. You can do that way also. That also works. But there. So if you give me two vectors, and if you ask me somewhere in the middle of the line, I can use this and figure it out. Where m and n is that ratio of that point, how it is dividing. Clear, everyone?
Sir, why minus RP, sir?
Minus I.
Sir, fourth line में minus RP.
What is PO? You're going from P to O, right? Aren't you going opposite to RP?
Yes, sir.
So minus RP, no, that is. O to P is plus R2, plus RP, right? If you go P to it is minus RP. Reverse of it. Next thing, centroid of a triangle. So if someone gives you vectors, and how do you find the centroid of a triangle? So let's say we have a triangle. So this point ka vector is R1 bar. This point is R2 bar and this point is R3 bar, meaning how is that? So this is your R2 bar. This is R1 bar. This is R3 bar. So basically the three vertices, right? What you have, these are the vectors. I will not do it. So the centroid will be somewhere here. I hope you know what's a centroid, right? If you drop the lines to the midpoint, the point of intersection. So just remember this. The position vector of the centroid will be R1 bar, R2 bar plus R3 bar by 3. Remember this. So if I know the vertices of the three coordinates of the three vertices, the centroid will be simply just add them and divide by 3. More of a max oriented. You'll have a chapter called vectors in max. They will teach even much more complex things. For now, this much is sufficient for us. Yeah. Let's see a question. So let's say magnitude of three vectors is given. So A bar, B bar, C bar. So we have three vectors. You know the magnitudes, you don't know the directions. Vectors is given. So the question is, you can arrange them however you want. The direction is up to you, your call. So which of the following set of vectors can give us zero resultant? Right? If they give zero resultant, find the angles between them. For zero resultant. So question will be like this. Let's say this is 3, 3, and 3. So the question is this. I have three vectors. The magnitude is 3, 3, 3. All three equal. The directions are not given. You can choose however you want. So can I put these three vectors in such a way? Can I get a zero vector? For example, say, can I put 3, 3, and 3 like this? Will this give me 0? This will not give me 0. Can I put 3 and 3 and 3 like this? Will this give me 0?
No.
So you can do whatever you want. Matlab, you can arrange them however you want. But is it possible to get a zero vector from this? If it is possible, then what are the angles between them? Are you getting the question? I'll show you this one. Listen. So 3, 3, 3. How do we do that? So one thing it is clear here. So they should form an equilateral triangle. Isn't it? The three sides will form equilateral triangle. So what is the angle between the vectors? Don't say 60. You have to put them tail to tail. The angles between them is 120, 120, and 120. You're getting it? So the answer for this question is yes, it can form a zero resultant, and the angle between them is 120, 120, and 120. Understood what I'm asking? There. So like that, you have to give me this. So 8, 6, 10. 3, 4, 8. 1, 1, 2. 6, 6, 7. Get it. Let's make this thing 1 root 3 and 2. So B will form again a right angle triangle, isn't it? 3, 4, 5 था वो. Hmm. 8, 6, 10. So now, first of all, how do you know something is forming a zero vector? So this is the statement there. Remember, we wrote this statement here. If 3 vectors form the sides of a triangle, this is the thing there. If 3 vectors can form the sides of a triangle, then you can get a zero vector. And what is the property of a triangle? Sum of 2 sides must be greater than equal the third side, greater than the third side. So there. So that is what you need to check. So you need not check each and everything. So this is the statement there. If the vectors can make a triangle when joined head to tail, we get a zero vector. So you should get sum of 2 sides must be greater than the third side. So you can look and tell someone is not working here. Who is that? See na, 3 plus 4 can't be, is not greater than 8. It can't form a triangle. So C is not possible. You can't get a zero vector there. Now some people will say like this, sir, what if I draw like this 3, 4 and 8 like this? See, it is forming a triangle. Again, you're missing the point. You should join them head to tail. Look at this thing. If you walk like this, what is the displacement? Isn't this the displacement? You're not getting a zero displacement, right? The vector has to stop at the last tail. You can't overshoot like this. So what is the answer for 8, 6, 10? 8, 6, and 10. So this angle is 53 and this angle is 37. We have done this. So yes, it can get a zero vector. 8, 6, and 10. So this angle will be 127, 143, and 90. So this is already done. C is not possible. Why? The sum of 2 sides, 3 plus 4, is not greater than 8. So that guy is gone. What about D? 1 root 3 2. I think that is also an equivalent right angle triangle. Is it a right angle triangle? No, that's 1, 2, root 3 is what? That is nothing. 1, 2, and root 3, na? Yeah, I can make a right angle triangle. 1, root 3, and this guy is 2. So what are the angles here? This guy will be 60, this guy will be 30, and this guy will be 90. So arrange them. This is 1, this is 2, this is root 3. This is 90, this is 120, this is 150. Getting this, everyone? Any doubt so far? What about E? Can 6, 6, 7 form a triangle? It can, right? 6 plus 6 is 12, greater than 7. It is an isosceles triangle. What about the angles though? Angles not be great.
Sir, is it very complex? The answer for each question.
Very complex matlab hai, thoda answer weird, but it is not that bad. See, I can do like this. I'll take 7. I'll take this 6. I'll take this as 6. I can use cosine rule, right? So if I take this angle as theta, what is cos theta? If you guys remember cosine rule, 6 square plus 6 square minus 7 square by 2 into 6 into 6. Because it's an isosceles triangle, this is alpha and this is alpha. So theta plus 2 alpha is 180. So if I know theta, I also know alpha. 180 minus theta by 2. Then we have to slide this thing. This is 7. This is 6. This is 6. So this angle will be 180 minus alpha. This angle will be 180 minus alpha. This angle will be 180 minus theta. That's your answer. Sure, everyone? And you can get theta and alpha from the cosine rule. Yeah, it can form a triangle. The answer is not a normal, standard angles, but this is how you do that. Is this clear, everyone? Take a small break. Come back by 9:43. Any doubt so far? Anything you're not clear, please ask me. Go, come back and hi, Yashvi.
The D
Which one? D.
D1. Yeah. How are you
Uh,
getting the angles as 60 and 30?
tan 60 opposite side by adjacent side, na?
Okay.
Root 3 by 1.
Okay. Thank you.
Mm-hmm.
Sir,
Chalo. Haan, yeah.
can I ask my exercise out?
What is the doubt?
Sir, the three vectors are given and
Mhm.
angle between each of them is 60 degree.
I sent you this thing, na, right now.
Or is it?
You didn't see? Zoom mein dekho. I just sent it to you in the starting of the class.
So how do you solve it? It was in the exercise.
Did you even get the diagram?
No, sir. I mean the three vectors are like this in 3D, right?
ऐसा है ना.
Yeah.
They finished dot product for you.
So what is the dot product?
They have to teach you, but class के बाद
If we
discuss
can
करते
find the dot product, then we can use that a plus b plus c whole square
हैं.
identity.
वो हो जाएगा. You can do it with geometry also. I'll show you after the class. Yep. Next thing. चलो क्या सुनिए वीडियो polygon law of vectors. So this is an extension of a triangle law. If n vectors are joined head to tail, the resultant is from remaining tail to remaining head. So if you have vectors like this, let's say this is AB, BC, DE, and F like this. So then this statement says, think of like this, if a person is walking like this, that displacement vector will be from here to here, isn't it? AF bar. So if you go from A to B, and then you go from B to C, and then you go from C to D, and then if you go from D to E, and then if you go from E to F, this is as good as walking directly from A to F. Make sense? That's it. So polygon law is nothing but an extension of a triangle law. In triangle law, we have three vectors. You can take n vectors and actually do the same story. Is that clear, everyone? Clear? Let's say a question based on this. We have a regular hexagon. What do you mean by regular hexagon? All sides are equal. Let's say this is A, B, C, D, E, F, and O is the center. The first question, OA bar, OB bar, OC bar, OD bar, OE bar, FO bar is equal to what? AB bar, AC bar, AD bar, AE bar, AF bar is n times AO bar. Find n. Let's get these two. Be careful. First one may I reversed this thing. It is not OF bar. So we got a hexagon here with 6 vertices A, B, C, D, F, and O is the center. So if I add the vectors OA, OB, OC, OD, OE, and FO, what will I get resultant? Second is AB. Second one is this thing, say. I'm adding AB, AC, AD, AE, AF. I'm adding these 5 vectors. Then what is the resultant? Get the first one. I'll give you a minute. It's an easy one. I'll show you. But first you try. It's okay if you don't get an answer, but try something. Let's see the first one. This is easy. Listen carefully, see. O to A. So this is OA. O to D, this is OD. Don't these two cancel out? Aren't these two vectors equal and opposite? So OA and OD will cancel. OB bar is this. OE bar is this. So OB and OE are opposite. They will cancel. This is O2C. This is F2O. They're actually adding up. So this is actually OC bar plus FO bar. You can clearly see this is as good as, you can write it as FC bar, or you can write 2 times OC bar, or you can write 2 times FO bar. All are valid. Is that clear, everyone? So when you add all these things, the resultant will be in the horizontal direction. Clear what I'm asking? What about the second part? AB, AC, AD, AE, AF. No, Trishi, that's not the answer. Again, just to show you, AB is this vector, AC is this vector, AD is this vector, this and this. Remember, you just can't directly add the magnitudes. For example, if this is 1, 2, 3, 2, and 1, you can't say answer is 1 plus 2 plus 3 plus 2 plus 1. Vectors you don't add like that. I plus j is not 2, right? You don't add like that. You have to take the things. How will you do this? Think it's a good one. Any ideas? See, one, you can do brute force. Actually, you can just get the magnitudes I cap, j cap, and do, but there's a better way. A, B, C, D, E, F. So you want to find AB bar plus AC bar So listen carefully what we do. So AB is fine. Let's leave it like that. But when you go from A to C, can I write AC bar like this? So AB bar plus AC bar can be written as AB bar plus BC bar. Just try to get the meaning of it. You're going from A to C. It is as good as going from A to B and B to C. You'll go from A to C, right? AD bar, let's leave it as AD bar only because you're asking in terms of AO bar. So if this is O, you can clearly see here AO plus OD is AD bar, and we know it's a regular hexagon, so sides are equal. So 2 times AO bar is AD bar, isn't it? So this vector is 2 times of this vector. Okay, so I'll just leave AD bar as AD bar only. What about AE bar? You want to go from A to E. So I can write this thing as you can go from A to D and D to E. What is AF bar? AF bar, I want to go from A to F, so I'll go from A to D, then I'll go from D to E, then I'll go from E to F. I can reach F like this also. Is this clear, everyone? Now look in the picture. AB is this way, DE is this way, meaning AB and DE will cancel. So one AB, one DE will cancel, one AB, one DE will cancel. Similarly, if you look at this BC and EF are opposite. So one BC will cancel with one EF. You are left with AD, AD, and AD. This is 3 times AD bar. And one each AD is 2 times AO. So this is 3 times, 2 times AO bar. This is 6 times AO bar. N is equal to 6. Is that making sense what we did? So instead of just finding each vector, I used polygon law and I simplified it. So the idea here is these vectors will cancel out opposite ones. Are you clear what we did? So you wanted to find AB, AC, AD, AF. So AB, let it be like that. AC can be written as AB plus BC. AD, I will leave it like that. AE is nothing but you want to go from A to E. I can go round, but why to do that? I can go just A to D and D to E. You want to go from A to F, you can go from A to D, D to E, and E to F. And there, AB and DE will cancel. BC and DF will cancel. You are just left out with 3 AD. So I will write that thing here. So AB and DE are opposite. So they will cancel out. Similarly, BC and DF are opposite. Is this clear, everyone? Any doubts on this? So there is a variation of this question like this. Suppose the same thing, if I make it like this, let's say we have something like this. Let's say this is 1. This was 2. Someone asked me this thing last time also. So basically it is still in hexagon, but I'm making the sides bigger, 3. This is 4. This is 5. And this is 6. You're getting how is the vectors? So the sides have become 1, 2, 3, 4, 5, 6. It is still a hexagon, but the angles have become like this. Meaning this angle will be 60. 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 This angle will be 60 and so on. Meaning if I make all of them 1, 1, 1, 1, 1, I would have got a proper hexagon. But someone decided to make this second one double, this one triple, this one 4 times, this one 5 times, and this one 6 times. And then when you joined them, you got a shape like this. So this was A, B, C, D, E, F, and G. Find the length of the line AG bar. What is this length of this line? No, Srihari, that's not the answer. Did you guys get the question? Instead of making all the 6 sides equal, right, Trishi? You made the sides 1, 2, 3, 4, 5, 6. You extended each side of an hexagon like this. So now it won't form a closed figure, right? Then what is the distance from A to G? Anyone not clear with the diagram, please ask me. Diagram is clear, give it a try, you got a minute. It's not root 3. Let's see. Look at this thing. This is 1, this is 4. Aren't these two opposite? I'll just mark them with colors. See, if you take this one and this one, both are opposite, right? 4 is that way, 1 is this way. What is the resultant? 4 minus 1 is 3. If I take this one green line and this one green line, that is 5 and this is 2. What is the resultant? 3. If you take this one and coloring it with black and this thing, 6 minus 3, both are opposite. What is that one? That is also 3. Isn't it? So basically, if you had completed this regular hexagon, isn't this how it would have looked? So am I not asking you directly the distance between these 2 points? This was A and this was J. So if this was 3, 3, 3, how much was this? 6, no? You guys know that, right? See, in a regular hexagon, what are the sides? You should know the properties of the lengths of this thing. So a regular hexagon is made of nothing but 6 equilateral triangles. If you join all the sides here, there you will get 6 pieces like this. So if this is side A, this is also A, this is also A, this is also A, this is also A. So this length in the middle will be 2A. Clear, everyone? Got it? So AG will be 6. Easy? Again, don't add 3 plus 3 plus 3. That is wrong. These are vectors. You have to add them vectorially. Any doubts on this? Easy question, simple one, but yeah, you need to think that you can cancel the opposite things. It was a better one. Yeah, there is another way to do also. You can take it as components, but okay. Next one. So that is a bit about the polygon law. The next thing, the parallelogram law of vectors. It is all these shapes only. So we finished triangle, polygon, now we came to parallelogram law. So consider, this is not really a big deal. We have actually done, this vector resolution component. This is a joke. So consider vectors A bar and B bar with an angle theta between them. So what this law says is, if you take 2 vectors, A bar and B bar, now since we know the vectors can be shifted parallelly, they will form the sides of a parallelogram. So this guy becomes a parallelogram. So this becomes A bar and this becomes B bar. So the resultant of these 2 vectors will be the diagonal C bar. So when you join them tail to tail, so the remaining tail and the remaining head. So the thing is, we need to find this magnitude. So how do we do this? A little bit of a geometry, or you can use a vector resolution. It is the same thing. So listen carefully. So once you make this parallelogram, so let's call this O, let's call this A, let's call this B, and let's call this C. So you want to find the length of this diagonal. So from here, drop a perpendicular. This angle will be D. This angle is theta. This angle is also theta. So theta is given. That is the angle between the vectors. And this CA ka length is, so this side is A and this side is B. Opposite side is B sine theta. The adjacent side is B cos theta. This is point D. So if you take the triangle OCD, OC square, it's a Pythagoras theorem. OC square will be OD square plus CD square. So this will be C square. That's your OD will be A plus B cos theta square. And CD will be B sin theta square. Now, if you expand this, you will end up with, I'll just call this thing as C square, A square plus B square 2AB cos theta plus B square cos square theta B square sin square theta. Sin square theta plus cos square theta is 1. So we get C square. C is equal to root over A square plus B square plus 2AB cos theta. There. This is how you can find the diagonal of a parallelogram if you know the two sides and one angle. And if you think about it, doesn't
Sir,
this
is it the
kind
proof?
of come again?
Sir, is it the proof of cosine law, sir?
Yeah. If you have patience, you will listen. So this thing is nothing but cosine rule, isn't it? We have just adjusted that. It looks like cosine rule. It is there. So that is one formula there. And what is the angle between the vectors here? So if I take now there is a much better way to do this. Actually, this is a little boring way of doing it. But HSC may they'll ask you like this. But luckily, 11th HSC may 11 we don't have 11th HSC boards. Listen to this thing. This is a much better way to do this. You're telling me this is vector A bar. This is vector B bar, and this is an angle theta between them. So if you give me vectors like this, what do? I resolve them into components. So I will resolve this B into B cos theta. I'll resolve this into B sin theta. So this guy becomes horizontally A plus B cos theta. And it becomes vertically B sin theta. And what is the resultant for this? So the resultant will be root over A plus B cos theta ka square plus B sin theta ka square. Exactly same thing we got. See, there is no difference. You're getting it. So vector resolution is actually a more superior way. This is a little dumb, but okay. So this will give you the magnitude. And if you take this resultant here, alpha, then we get the angle between the vectors. So we get tan alpha will be the opposite side, which is B sin theta, by the adjacent side, which is A plus B cos theta. Suppose if I take this angle, which is beta, tan beta will be A sin theta by B plus A cos theta. A and B will flip. So here alpha is angle between the resultant A bar and C bar. Beta is angle between the resultant and B bar. I think you can note down this. You will need this. These are the main results. So what is the use of this? If you give me two vectors, right? And if you give an angle between them, it is useful to find the magnitude of this. Wait, I'll do one thing. I'll write this in a more usable form in the next page. So this is A bar, this is B bar, and this is theta. If you add these two, you will get a vector like this. This is your resultant vector C bar. So C bar is A bar plus B bar, the resultant of these two. This is alpha, this is beta. So the magnitude of C bar, which is mod of A plus B bar. So when you say A plus B, it is C bar. When you add A plus B, you'll get C. This is a root over A square plus B square plus 2AB cos theta. You can note down this stuff. Tan alpha will be B sin theta by A plus B cos theta. There. Put it up. You will need this.
Sir, can you please tell how you got tan beta?
Same thing, ना? Tan beta के लिए क्या करेंगे? So what was this component? This was A plus B cos theta, and this was B sin theta. So let's do the reverse way, na? See, I can keep A and B wherever I want, isn't it? So let me keep B this way, and let's keep A this way. Now, isn't this beta? This was alpha, right? I'm just reversing the orientation. Abhi now, if you take the components, what will I get? This will be horizontally B plus A cos theta, and the vertical will be A sin theta. Now this will be the resultant C bar, and this will be beta. So tan beta will be opposite side by adjacent side. Clear? See, did I tell you where is A and where is B? I can keep wherever I want, right? So for the first case, put A horizontally. Second case, keep B horizontally. See, basically you're just turning the page like this, isn't it? You're just turning your head and you're just changing the orientation. But got it? How we got this? So what is this useful for exactly parallelogram law? So this is useful. Basically, it's like a cosine rule, like what Srihari was saying. So this was useful to find angles between vectors if you know the magnitudes. When only magnitudes are given. Let's see a few questions on this, you'll get the hang of it. So let me show an example, but all copied? Example say, they will say like this. Let's say we have a vector mod A bar is equal to 3, mod B bar is equal to 3, mod C bar is equal to 3, and C bar is equal to A plus B bar. Now try to understand this verbally. What does this mean? When I'm adding two vectors A bar and B bar whose magnitudes are equal, the resultant of these two vectors is also 3. You're getting it? That's what it is trying to say. So then the question would be find the angle between A bar and B bar. And we know this thing, it will form an equilateral triangle, but okay. This is how they'll train questions. Then what we do? C bar will be C is equal to root over A square plus B square plus 2AB cos theta. Remember, theta is the angle between A bar and B bar. Substitute the values here. 3 is equal to root over 3 square, 2 into 3 into 3 into cos theta. Square it on both sides. You will get 9, 18 cos theta. Cos theta is equal to minus half. Theta is 120 degrees. Easy. So like this, if you give me the three sides, I can get you the angles. So you know how is this vectors actually? This is A bar, this is B bar, and the angle between them is 120. When you add these two vectors, the result is coming like this. C bar. So this was, the magnitude is 3. That is also 3 and 3. Is that clear, everyone? So if you keep two vectors of same magnitude at an angle 120, then the resultant also will be same as A and B. Minus half is 120.
Sir, aren't these the sides of an hexagon?
Come again.
Sir, that is why OA in that hexagon was same as AB, right?
Oh, A was same as A, B. In this you're saying?
Yes, sir.
No, it was a regular hexagon. Basically, these were equilateral triangles. So
Okay.
that has nothing to do with this. So there are only 3, right? For hexagon, you need 6. There are only 2 vectors here. All got this? Now let's see one more like this. Let's say mod A bar is 3, mod B bar is 4, mod C bar is 6, and C bar is A bar plus B bar. Find angle between A bar and B bar. So when you add A plus B, you got C. That is the meaning of it. Find angle between A bar and C bar.
Sir, are there any standard angles?
No, these are not standard angles. You'll get weird ones. You can leave the answer in terms of cos theta, you can leave it like that. No need to get the angles. The first was easy, just apply the formula there. So we have C is equal to root over A square plus B square plus 2AB cos theta. Substitute here, this will be 6 square, 3 square, 4 square, 2 into 3 into 4 into cos theta. That is 36 minus 16, 20 minus 9, 11. So we have cos theta 11 by 24. Yeah, that's your answer. Check your calculations, there's nothing there. So yeah, cos inverse 11 by 24. What about angle between A and C? Now we can use the formula there. Tan alpha B sin theta plus A plus B cos theta. Then from cos theta, we need to get sin theta. There is a better way actually. Any idea how to do something else? So from here, I can get it and substitute, then I'll get the answer. But there's a better way. Now, what if you don't remember the formula in the exam, right? I too can't remember this formula. So listen to the alternator. So you want angle between A and C, right? So can I rearrange this like this? B bar is C bar minus A bar. I'll just shift it that side, right? So B bar can be written as C bar plus minus A bar. Is that clear, everyone? So this will give me what? So if I try to, so B bar is nothing but C bar minus A bar. So now if I use the formula, I'll get B square. So B is equal to root over C square plus A square plus 2 into C into minus A into cos alpha, where alpha is the angle between A and C. You getting what we did? If you add C and minus A, you will get alpha. Is that clear, everyone? So Substitute the values. So this guy will be 16. This will be 36. 9 plus that will be a minus sign there. 2 into C is 12 minus 336 cos alpha. P is 4. Yeah. Square it on both sides. 16, 45. How much is this? Numbers are bad again. 29 by 36. Yeah. This is another way to do. But if you can remember the formula, this also works. But this will give you tan alpha. How much is this? B is 4. So what is this thing? Yeah, numbers are super bad, right? 121 by 24 square. Okay, I will leave it to you. You can check it out. Is this clear, everyone? There. People look tired today. I know it is a lot of theory today. Like last class, right? We had a lot of problems to do. But you're almost done. I think by next week we'll wrap up the chapter also. After that, we'll start with calculus. Okay, we'll do more problems in there. Let's do one last question and we'll wrap it up with that. This was a good question. We are going to do this anyways in dot product, but I wanted to show you something. And this was a doubt of Arya also. So we have three vectors. Listen to this thing. We will just do it roughly. We will see that later in a much better way. I have three vectors, A bar, B bar, C bar, right? All have same magnitude. So mod A bar is equal to mod B bar is equal to mod C bar is equal to 2. And now listen to this statement. Angle between any two vectors is 60 degrees. And the question was find A bar plus B bar plus C bar come mod. Can you tell me how will these three vectors look like? We have three vectors, A bar, B bar, C bar, all have same magnitude, and angle between any two vectors is 60 degrees. If you add three vectors like this, then what will be the resultant? Forget about solving the equation. I just want you to tell me how will the three vectors look like. Angle between A and B, 60. Angle between B and C, 60. Angle between A and C, 60.
Some 3D shapes, sir. With
Yeah.
three spikes.
Let others say. Let others try, Arya. Let others try. I know you know. Let others try. You got an answer, always type in the chat box. We want others also to get an opportunity. So when I asked this last time, someone told like this, sir, I'll put A bar like this, B bar like this. So this is 60. This is 60. Great, but A and B ka bhi 120 ho gaya na? You're getting it. If you put AB 60, AC 60, then B and C will be 120. So these three vectors, if you see now, they can't be in the same plane. You know how they will look? This is the shape they would form. Look at the vector. So this is A bar, this is B bar, this is C bar. This is called a tetrahedron. Meaning, I'll show it here. See, देखो, angles के sides का बीच में. This one, this angle is 60. This one and this one, this angle is 60. This one and this one, this angle is 60. You're getting how it is? If you're looking into my screen, they look like this. Like a spikes, like a pyramid ka top mein, the three sides like this. So this angle is 60, this angle is 60, and this angle is 60. The three vectors are out of the plane. They can't be in the same plane. You can't get 60, 60 when they're in the plane. Is that clear, everyone? So now I'm saying each vector ka magnitude is 2, 2, 2. If I add these three vectors, what will be the resultant? Is the question understood now?
Yes, sir.
So this shape is actually a tetrahedron. That is the name of this shape. And the property of a tetrahedron, right? If you see, all these faces are equilateral triangles. All sides are equal. In a tetrahedron, all faces are equilateral triangle. So we will try to do this with geometry right now, but later on I'll teach you something called dot product. You will get the answer pretty fast. But for now, we will, let's see, let's imagine with geometry and try to do this thing. Ishman, that's not the answer. Think, I'll give you 2 minutes. Everyone should try. So I have 3 vectors, 2, 2, 2. So this guy is 2, this guy is 2, and this guy is also 2. Angle between any 2 of them is 60 degrees. So if you add these 3 vectors, it is clear they'll be pushing it down vertically. So how much is that resultant? You can't add 2 plus 2 plus 2 because they're not in the same direction. No, it's not 3 root 6. It's not root 28. Samyak, that is right. We have an answer. Don't worry about the answer. Just imagine, visualize what is happening, how are the forces and stuff. What I'm teaching you now will be little brute force, like we are just doing with angles and stuff. When we actually use, there's something called a dot product that will make your life really easy. You're pretty close, Ravya. Well, root part is fine, but before that, that number is bad. It's not 3. I know you got it. See why that is right now. Let's see the geometry part. Listen carefully, I'll show you the geometry. This is what I keep saying. You should be able to visualize stuff in 3D. Look at this thing. Let's take one of them. So if I take this guy, so from the top here, O, if I drop a perpendicular, this will go and fall on the centroid of the base. Agreed? Symmetry, right? When you drop a perpendicular from the top, that will form at the centroid of the base triangle. So if I take this point here, let's call it A. From here, if you drop a line like this, isn't that a right angle triangle? What is this thing? This is A. That is the side of our tetrahedron. What about this length here? In an equilateral triangle, what is the distance between the centroid and the vertex? This is something I told you. You should definitely remember that. In an equilateral triangle, from the centroid to the vertex, it will be 2/3 of the height. This will be 2/3 of the height. And what is the height? Height is root 3a by 2. So this guy will be a by root 3. So this length is a by root 3. So from here, I found the angle between this side and this one. Let's call it theta. Sure. So where I got sine theta is equal to a by root 3 by a, which is 1 by root 3. So I found the angle between this side and the vertical line. Any doubts on this? Once I got this, so this is the force, isn't it? 2. I can resolve this into components. This will be 2 cos theta. This will be 2 sine theta. Agreed? And now look at the components. We are done actually. So the components will look like this. So we have 2 cos theta will come down, 2 cos theta, 2 sine theta. The other guy, this will be 2 sine theta. This guy will be 2 sine theta. So the 2 sine thetas will form like a Y shape. And the 2 cos thetas will all add up downward. Is that making sense? And just now we saw if you have three sides and if they make an angle of 120 between them, what will be the resultant? The sine thetas will cancel off. So the 2 sine theta, 2 sine theta, 2 sine theta, all are equal in magnitude, and you can clearly see they're forming 120 degrees between each of them. Or if you're not convinced, I can calculate it for you. This angle is 60 and this angle is 60. If you resolve them into components, you will get 2 sine theta cos 60. This will be 2 sine theta cos 60. Cos 60 is half. So these two will cancel with this guy. So that red lines will cancel off. What is left? You're left with 3 times 2 cos theta. And what is cos theta? Sine theta is root 1 by root 3. So sine theta is 1, root 3, and this is root 2. You can make a triangle there. Or you can use root over 1 minus sine square theta. Cos theta is root over 2 by 3. So this will be 6 into root over 2 by 3. How much is this? 2 root 6. That is 2 into 3. 2 will be out. Yeah, that is your answer. Is this clear, everyone? Did you guys get what we did? We just divided into 3 parts. Arya, clear with this?
Yes, sir.
You know how to make it more deadly? Let's say mod A is equal to 2, mod B is equal to 3, and mod C is equal to 4. Idea is still the same.
Sir,
Hmm.
sir, how do we like solve this using dot product?
Let me teach you dot product in the next class. I'll show you. It's
Sir,
not tough.
and
I'll show you. Wait till the end of the class. But is
can
this
I
clear,
use
everyone?
like this identity a plus b plus c whole square?
You can do that. If you have a plus b plus c ka square, this will be a square plus b square plus c square plus 2a bar dot b bar dot आएगा वो 2b bar dot c bar plus 2c bar dot a bar. So let me teach you dot product, and you'll know. But is this question clear, everyone? The tetrahedron. So the main thing in this question now is this word, angle between any two vectors is 60. People get confused. How the hell did you get 60? The vectors are not in the plane. Is that clear, everyone? This is how you can do with geometry. But like I said, there is a better way to do in vectors. I'll show you. Okay, with that we'll wrap up for the day. So next class when we catch up, we will continue with the parallelogram law, and then we'll do something called scalar dot product. So yeah, that will be fun. Yeah, vectors chapter, right? If you see, it is mostly like still a little math oriented only. So the actual chapters would start from kinematics. So after this, we still have calculus and then kinematics. So game begins then. But we need to get all these basics right now properly. Okay, with that we'll wrap up for the day. So anyone has any doubts, anything, you can please stay back, or else you're free to leave. So take care, stay safe. I'll see you on
Sir.
Thursday at the same time.